In problem 2, we want to find the distance from a point to a line. So we have point A, which is 3, 0, and point B, and which is 7, negative 1. And we're trying to find the distance between the line that creates and point C. So the first thing I need to do is write the equation of the line through points A and B. So I need to figure out the slope. I could tell it's negative. And if I count the slope here, down 1 and over 1, 2, 3, 4. So I'm going to be using that my slope is a negative 1/4. And then I'm going to take one point that's on the line, and I'm going to select point A, which is 3, 0, and I'm going to use point slope form. To substitute in this information. So y minus the y value is equal to the slope times x minus the x coordinate. Y minus 0 is just y. We're going to distribute negative 1/4 x, and that's going to be a positive 3/4. So that is the equation of this line. We're going to do a visual here that this y-intercept, it looks like it should be between 0 and 1, so 3/4 makes sense. So our first step of writing the equation of the line seems to be accurate. Now step 2, we're going to write the equation of the line through point C. So C is the point, ordered pair 1, 9, and we're going to make it perpendicular to the slope of the line AB. And so therefore the perpendicular slope of negative 1/4 is going to be 4. So that is the information we're using there. Once again, we are using our point slope form and substituting in y minus our y coordinate equals our slope times x minus our x coordinate. And our two steps, distributive property, and then add the 9. And so therefore the equation of the line through C that is perpendicular to line AB is y equals 4x plus 5. Now in step 3, we're going to take these two equations of lines, and we're going to use what we know about solving systems to find the point of intersection. I'm going to move this over a little bit. Excuse me. And we're going to take our negative, finding our point of intersection, we're going to use substitution. And so we're going to take the first equation, negative 1/4 x plus 3/4, and we're going to set it equal to this second equation, which is 4x plus 5. And then we're going to solve this to find the point of intersection. So I see some fractions here. I'm going to take and multiply by 4 to clear those fractions. So I'm going to have a negative x plus 3 equals 16x plus 20. So I cleared those fractions out, and then I'm just going to move all my variables to one side and all my constants to the other side, and divide this out to get x equals negative 1. So I know the first part of my answer is negative 1. And now I'm just going to go back. Remember, you can go back into either original equation. I would probably choose the one without fractions. And in place of the x value, you're now going to put in what you just found it to be, negative 1. And when we do that, we can find that the corresponding y value then is going to be 1. Okay. Okay, so now we know that here at the point -1, 1, that is where those two lines would intersect, and we now need to find the distance between this point here and our point C that we've been using, which is 1, 9. And so our distance formula, we're going to take the difference in the x's squared and the difference in our y's squared. So I'm going to have, let's see, 2 squared 4 and 9 squared 64. So that's going to give me the square root of 68. Then I'm going to need to simplify that radical. The square root of 68, the square root of 4 times the square root of 17. And we're going to have 2 radical 17 units for our answer.